Let's do a quick comparison sort of between the washers and shells methods. A washer looks like this. Its inner and outer radius are not tiny, like the inner radius here might be little r, and the outer radius you might think of as big R. What is tiny is the thickness. Remember we were using like old CDs or DVDs where they have a hole inside that's maybe a centimeter or whatever, but the thickness is only a millimeter. A shell, remember we used a sheet of paper wrapped around to show that. So that thickness is tiny in this direction rather than in that direction. So one of these I'm going to call the thickness dx and the other one dy. Which one is which? So here, this is the thickness, and I would say that's in the y direction. So I'd call that dy. Here, the thickness is shown going left to right, so I would call that dx. In both cases here, I'm showing a shape revolved around the y-axis, but that's not how we first learned about washers. We first learned about washers when we were revolving f of x around the x-axis. So let's kind of quiz ourselves. If you have a function y equals f of x as usual, and you rotate it around the x-axis, that's this one, are you going to use shells, washers, disks? What do you think? You're going to use disks or washers, right? And f of x is the radius of what you're revolving around the x-axis. If you rotate around the y-axis, then you're going to use shells. You're taking this function and moving it around that way. And there, f of x is the height of the shell, and x is the radius. All right, so maybe that helps get things firmer in your mind.